This is Unit 1 for AS Statistics. So our first unit is collecting and presenting data, and we're looking first of all then at populations and samples, all stuff you've sort of done before really in GCSE, but we'll just run through it again. So the population is all of the values, individuals that you're interested in. Quite often it is impossible or not feasible to measure the values for an entire population, and so we would take a sample. For example, the population, every person living in the UK, we measure this in a census every 10 years. A sample would be to take a sample then of 1,000 random people who live in the UK and ask their opinions, and assume then that that's a good representation of all the people in the UK, rather than ask every single person. When we're taking a sample, we need to consider several factors, and we need to ensure that the sample will be free from bias. A sample must be large enough to be representative of the population. It must reflect the population. It is important to note that different samples will give different results. For example, in a year 13 class, year 13 maths class, if I want to take a sample of all year 13s, a maths class mightn't be a good representation because those are all people who do maths. So you just need to be careful to get a good kind of thing that does reflect the population. There's no minimum sample size for a poll which is acceptable, but around 1,000 has become the established norm for a nationwide opinion poll of Great Britain. There are several ways in which you could choose your sample, however random sampling and stratified sampling are the most popular. Random sampling then. So a sampling method, the items in a sample are chosen by a random procedure such as drawing tickets out of a box or using a random number generator. Every possible sample of required size has the same probability of being selected. One way to achieve this for a finite population, for every member of the population to give an equal chance of being selected, providing sampling is without replacement and selections are independent of each other. Simple random sampling is not always possible because you may not have a list of every member of the population. Other one which is very popular in a stratified sample. So if the parent population can be divided into subgroups or strata, such as by age or gender, then stratified sampling ensures that all strata are sampled. The subgroups are not expected to be representative of the population. If the numbers sampled from each of the strata are proportional to the sizes of the strata, then this is called proportional stratified sampling, otherwise weighting must be used. Sounds a bit complicated. Stratified sample is pretty straightforward. Say I have a class of 30 and I have 20 girls and I have 10 boys and I want to take a sample of 6 people out of that. I could pick 3 and 3, but that's not stratified, that's not representative of this class, so I would want to pick 4 and 2 because that's in proportion then the way the boys and the girls are split up. That's all stratified sample is. Obviously the numbers work very easily for this, whereas the 6 and the 20 and the 10, so it's 4 and 2. Otherwise it's a wee bit more complicated and you don't always get whole numbers, but that's a general idea of stratified sampling. Over the page then, so bias in sampling. Sampling techniques sometimes run the risk of introducing bias into the sample. For example, if you survey passers-by in the middle of the morning on a working day, your sample may include a disproportionate number of people of retired age. If you want to get a representative of the people of Carrickfergus, for example, doing it at kind of 10 o'clock in the morning, a lot of people are going to be in work, so you're not going to get a good representation. If you want to take a sample, of fitness of the population of Carrickfergus, picking people just coming out of a gym every morning is not a good sample. They're all people who are generally going to be more fit. So it's things like that. Just be careful you don't put bias in your sample. If you post a survey on a website, the visitors to that site might not be representative of the population, or they might be those who hold particular strong opinions about the subject of the survey. On then to different types of data. So numerical data are expressed as numbers, and the values of these numbers have a numerical meaning. Categorical data does not need to be expressed in numbers. For example, coin tosses, numbers on a rugby shirt, we'll chat about that a bit more in a wee second. Or maybe something like pain level, how sore is something. Do you give it a number, out of 10? Sometimes they ask you to do that, it's very hard to work out. Gender would be another one. Car type, or eye color. All of these are of course data, but they don't have a numerical value to them. The rugby one is, they're numbered rugby from 1 to 15, but the point we're making is, 15 isn't better than 1, and so that's kind of why it's in the categorical data. Numerical data scores when a dice are thrown. In most games, if you throw a 6, it's better than scoring a 1, so the 6 has more value than the 1. That's the point we're kind of measuring there. Height is obviously kind of one, ones with a bigger number or taller. We're just pretty much saying that. So here, this is just about the rugby one. Numbers can be categorical data if they do not have a numerical meaning, as in, the number 8 isn't, 2 times as good as the number 4. That's not what that means in rugby. Numerical data can be further divided into discrete and continuous. Again, you've done this in year 9, so you should be all over it. If all the possible values for the data can be listed, the data then is discrete. So for example then, number of coins in pocket is a good example. Shoe sizes I always think is an excellent example, because people tend to think of discrete as just kind of whole numbers, but shoe sizes you can get half sizes, but it's still discrete because you can only get 8, 8.5, 9. You can't go in and get size 8.23. It doesn't make any sense. Or kind of ice skating scores is the same. You can get like a 5.8 or 5.9. So they would be examples of discrete data. Again, we have heights. For continuous data, again, it's just measured to a certain degree of accuracy or time for a race or something like that. So that's just a wee introduction then to our data.